Everybody, hello. Okay, so we are going to wait just a couple of minutes before starting so everyone can join, and then we will start the presentations. Hi to everyone who's joining. Morning, good afternoon. Hello, hi everybody.
You fix it.
Okay, so we have around 70 people. So I think we can start, and of course everyone is allowed to join even after. So yeah, thank you for joining this first stakeholder workshop for the Refresh project. I will leave the floor to Daniel, who's the coordinator of the project.
Hello, everyone. Thank you for joining. I will share the presentation. Okay. No. Sarà lo schermo. Okay. Are you able to see it?
Yes.
Okay, perfect. Okay, so thank you everybody for joining. I will run a little bit through the workshop agenda of today. So I will start with the introduction to the Refresh project, and then I will basically leave the floor to our technical partners to present their technologies that are involved in our project. So we will start with the smart blade cutting from Etat 9, the shredding and sorting technologies from MTB, the mechanical recycling technologies from GIS Recycling, the advanced thermal recycling from Gjenkraft, the microwave assisted pyrolysis from CIRCE, the thermochemical treatment of dust and fines from Enecolab. Lastly, the regulatory challenges for the blade circularity from EuCIA. And then we will have at the end the Q&A session. So you will just put your questions in the comments or in the chat. I don't know if, in the comments. So we will answer those questions at the end of the sessions. So we'll start now from the quick overview of the project. So the refresh project, which it's about the recycling of the wind blades, and we have a consortium which is located in Europe, and we have waste recycling and remanufacturing companies. We have engineering consulting companies, research and development companies. Then we have the dissemination and the communication parts that grants us the access to the stakeholders in the composite sector manufacturers from with the EuCIA part, and it's coordinated by RINA Consulting. So quick overview of the methodology of the project. So the concept is that we decommission the wind blades. From the decommissioning till the new end product, refresh is covering the whole secondary value chain. So we decommission the wind blades, and then there is the pre-treatment, and then the treated wind blades are sent to the different recycling processes. So the mechanical recycling, the thermochemical recycling, because every process gives us a new end product. Because this was the challenge number one when trying to recycle the wind blades, because if you try to just recover the material, it's a problem, because the virgin raw material is much more cheaper of the recycled ones. So we need to like add an added value, and that's why we opted for producing new end product from the recycling chain. Everything from here is managed, and every decommissioned wind blade pre-treated is then sent to the proper recycling process with a market check, a technical check, an environmental check, which is performed by a traceability and decision-making tool, which is deployed also in the framework of this project. So this is practically the digital brain of the whole process. So it gives us real-time tracking, information sharing, which is transparent, because it takes it keeps trace of the data that are from the composition, the technical condition, everything of that wind blade, which gains the data through the whole value chain. So the quality control is obviously enhanced, the efficiency and the secondary material acceptance are increased, and also we grant the regulatory compliance. So this can give us a digital passport, basically, of each product is exiting the refresh value chain. So speaking about the refresh value chain, we have here the conceptual map of who is doing what. So as I said before, we're starting from the decommissioned wind blade. So the first step of the pre-treatment is from État Neuf and MTB. And then we have either the repurposing of the wind blade after the first treatment, or either the recycling processes, the mechanical recycling and the thermal recycling processes, which give us some secondary product. For example, composite panels, we can recover fibers, we can recover chemicals from the epoxy resin matrix with the thermal treatments, and also we can recover energy with the dust and fines gasification process. And also there are the Setma, Tecnali, and Acciona, which are working the eco design. So we take those secondary product, and then we can finish the value chain by transform those products in end product like construction panel, urban furniture, or a 3D cement, and also other wind turbine components of second generation. So the eco design strategy here in the refresh project basically is it's all about the repurposing and the recycling. We have some examples that I have already cited before. So the formwork panels, something like from the repurposing, and also the 3D printed cement. These are some images of what I were talking about before. And those are some results from the sustainability analysis, the preliminary LCA results. So each project, each process was analyzed, and it shows every process here shows a lot of CO2 equivalent, which can be saved. And those are the preliminary LCA results. We will have the final one once the deployment phase is fully completed. To give you an idea on the timeline of the project, so we have from month 1, month 18, the project started on the 1st January of 2023. So we are currently at month 35. So the first phase was like the design phase, in which the process and plans were designed, and also the preliminary LCA was carried out. So we had to run through the go-no-go milestones, which was a go, and now we've been working in the integration testing phase with the experimental LCA and also the traceability platform, which will be made operative. So we are missing like 1 year of project basically. So okay, this was my introduction. So I think we can move now to the first presentations. So from Jean-Baptiste, if you want to share the screen.
Hi everybody. Does everybody see my screen?
Okay.
Okay.
Yes.
Thank you. Thank you,
we
Martina.
see it.
Hi, I'm Jean-Baptiste Strehaiano from Metanef, French guy, so sorry for my poor English. We work on the, I'm going to remind you just how it works and where we are in the project. We are at the beginning in the project, on the phase of cutting blades. So I will present you what we develop, please, to the project, the smart cutting of the blades. First of all, we have some constraints of the technology. We don't want we want to take care about the workers and the environment first of all. So we choose some technologies. We don't expose the workers, the safety workers, and keep the environment clean. On the second part, we want to cut some blades. The constraint of the project was blades between 50 and 80 meters long, so very huge blades. So we need some technology can cut some huge parts. So we take the technologies from the building demolition, and to cut precisely, we choose this kind of technology, circular saw and cable saw. Just to have a picture of the technology, We have the circular saw mounted on the excavator. We have a fast cutting, and we can cut some long board of the blade, so it can be reused or repurposed for other using. On another way, we can sort the material, and it's one of our fine things in our technologies, because we can sort the fiberglass and the carbon from the balsa or the form of the blades. On the other technologies, two complementary technologies are the circular saw and the wire saw. The mission of the wire saw is essentially to cut the roots, because it's a huge part, and we can also here sort the material of the metals of the root, and sort the metal from the resin and glass fiber. And we reach the tier 7 because we choose some technology already exist on the market. On another way, in order to sort the material in the blade, the most efficiency, we work with a decom blades project from the material passport of the decom blade project, and be more precise on this kind of passport in the way of the characterization of different parts of the blade, in order to see what can happen and what can be done with the different parts, and also sorting these materials at the beginning of the cutting and at the beginning of the value chain of the blade. The green treatment of smart cutting is on the center of the beginning of the value chain, because if you want some panels, some special shape, or entire parts of make some pellets or chips with the parts of the blade, in order to reuse or recycle the parts of the blade, we have to define the cutting before the operation, and so after that have some dimension and the position in the materials of the blades. With some drawing or specifications, we can cut some parts according of the drawings, and also with process criteria. It depends on if we have some mechanical treatment, if we want to, we work with MTB, with the shredder of MTB, in order to know which kind of dimension, which kind of materials they need in the shredder. And so according to the shredder capacity, we can cut the good shape and the good parts of the blade with a nice dimension. Okay. In the consortium also, we especially work with SETMA and EuCIA and GIS on a prototype of picnic table. So just an example to show what we can do with a blade, and also to show and open the mind of the capacity and what will happen during the process. Here we saw, in order to do this kind of furniture, we need some drawings, and with the drawings we can choose on the blade the good panel to do the good things with the good thickness, the good dimension, the aspect of the panels. And for this example, we send the panel to a water jet cutter, and after that deliver at Setman Ethernet, because we did two prototypes, and EuCIA make the visual for one prototype on the JEC event on the year 25, so this year. And the other prototype is on SETMA Technology Center, and was the top was made with a panel from GIS technology, where will be presented. Giorgio will present you this technology. So the innovation are the sorting material on site. Like I explained you just before, the preservation of the workers and their health and safety. Of course, preservation environment, because we are managing the dust, please to water. And also we decrease the water consumption, please to a filtration skid. We permit us to make the recirculation of processed water on the site. For us, the next step into the project will be a new cutting work site. In order to, now we have all the technology of cutting, of water keeping and dust management, and we want to optimize the water recycling. Of course, we want to improve the CO2 equivalent emission of the machine. And after this kind of optimization, we can go on to machine acquisition and industrialization of the whole process in order to show we are able to do the cutting, the smart cutting of blades in the best standard of environment. So if I can maybe suggest you a question, it can be how can optimize the cutting, protect workers and environment in the field, as well as make possible the recycling. So it means we can today say the health and safety of the teams and the environmental protection. It's a key consideration of the blade cutting method. It's one of our constraints at the beginning of the development of technology and method. So we are follow it since the beginning. And as defined by each recovery stream, the stream of the different channel of recycling and recovery needs to have, we think that they need to have a good quality of entrant of raw materials for the process in order to have a process more efficient. And we think the source of separation of materials is essential to supply revalorization channels. And so because we are at the beginning of the value chain, it's up to us to give to the other partners a good quality of materials for their process. So it's maybe quite quick, but if I relate at the beginning of the whole presentation of this afternoon, the other partners will be maybe angry. So thank you for your attention, and have a nice afternoon.
Thank you. I will share my screen for Guilhem, just a second.
So yes, good afternoon to everyone. Guilhem Grimaud speaking from MTB. So in Refresh project as presented, we mainly work on the shredding and sorting step. So just after a ton of cutting step.
Just a second,
And,
you should be able to see the presentation now. Okay, please go on. Thank you.
Okay, so yeah, you can move on next slide. Yeah, and the next one. Okay, so yeah, MTB is just after ETANF. So our main goal was to find what is a more efficient way of shredding and sorting for the wind blade, and focusing really on the recycling. So as presented by Daniel, ETANF already focused on repurposing. So what's coming to MTB is wind blade that cannot be repurposed, and only the shredded blades that we need to send for next steps of recycling GIS and from Gjenkraft or CIRCE. So next slide. What we learn from the first steps of refresh project is like we have a really large blade dimension, and the large blade dimension could be a big issue as we come for shredding, and we start with a movable shredder. This was the first step of the design, and we learned that it will be really hard to accommodate with all type of big blade, and also because the complex composite structure with a large different materials, if we shred all together, it's really hard after to do the sorting. So we go for a cutting blade, so innovative steps from ETANF that could also sort the carbon and the glass fiber. So we don't mix all together, because it was one of the key points that we cannot pass on for the sorting. Also, the dust emission during shredding is really a big issue, as presented by Jean-Baptiste. We need to avoid the dust for the operator, but also for the environment. So we go for shredding off-site, not on-site, because it will be better for the dust and also the shredding step. So the next slide. The solution we come from with is a prototype and a test of the pre-shredding equipment. So RSX 2300 from MTB. And what we learn also that the rotor and the blade inside the shredder is really important to get the right size of the material. So we do multiple tests since 2024 to learn what is the best shredding way. So on the next slide. So yeah, this is some of the key figures of the composition when we shred all the materials together, to just show you how much there is heterogeneity inside the materials. And we find a lot of different materials that cannot be sorted. So this is what we learned from the next slide. Yeah, so you can see on the right what we get. So the next slide, you see so there is still a lot of mixing between all the materials, and this is really too difficult to sort them. So next slide, what we come with is to have an intelligent cutting from the field, and we can sort the glass fiber blade and the carbon fiber part also, and the foam and balsa blade. With this sorting on the field and this intelligent cutting, we can go for a pre-shredding, and sometimes it's not necessary because the blade are at a site that is able for the direct shredding and also the sorting. So we can go for the next slide. Yeah, so this is what we get at the end. So on the left, this is the pre-shredding and the pre-cutting blade. And at the right, for example, this one is a glass fiber and a wood blade, and we can go for the sorting. So we get the quality of materials required by our partners, so Gjenkraft and other partners for the next steps of recycling. So the next slide is a summary of what we learn from the sorting and what is the next steps. So what we learn is really we get a good separation from composite, from wood and rigid foam, but we cannot sort glass fiber and carbon fiber, even if we test multiple mechanical dry separation, but also high technology optical sorting. and also a robotized picking solution. And for example, the robotized picking solution, we cannot success in getting a good recovery rate. So the best way is really this intelligent cutting steps before shredding. So that's it from my side. I leave the floor to the next one.
Thank you very much. Okay, so I think we have the presentation from Giorgio, so I can share it for you.
Thank you.
Just a second. Okay, sharing it. Okay, go on, please. Thank you.
Okay. Hello to all. This is the technology that we have developed with GS Recycling within the Refresh project. We have nearly completed and installed the new mechanical recycling line. GS Recycling makes mechanical recycling mostly of the part low density of the blade, since our process that use particles reduction and then a bonding agent to process is able to process material regardless of fiber, of resin, and of core material, even if it's all mixed. Next one, please. So this is the line, the industrial line that we are setting up now. In this day, it's mounting in our plant of Aviano. It's again something really large, probably one of the largest, or I think the largest in Europe recycling line for composite. It's dimensioned for 7,000 tons a year. Not hours, sorry, that's a mistake. With a press size of 550 5 meter 500 by 1 meter 35 with more than 6,000 tons power. Next one, please. What's the challenge? The challenge is, as we see in the before slides of Tandnef and MTB, the wind blades in reality are mostly made of in reality two different products. We have the root, we have the transition part, and then we have the wing part. In the wing part, we have much more core material respect composite with respect epoxy and fiberglass. And so what is important, what the challenge was to obtain, use the mechanical process where it makes sense for the low density material, because with our product, with our process, we can maintain and exploit the low density as an advantage, and use the other processes like you see later, the pyrolysis and so on, for the higher density full composite without core material, where also the core material may create problems. We did also some on-field evaluation, because it's very hard to find the real data about the wind blade composition from makers. Next one, please. So the core material makes the waste composite much less interesting, or if it's not forbidden, for the use in cement kilns, because it's a low density. So when we fill the kiln, we will fill with something that is a third of the weight of the mass. Lower the production output in any thermochemical process, and also complicate much the process with unwanted gases, byproducts, and residues. Our proposal, we are using the less interesting parts of blades from the concept of carbon fiber and glass fiber, the less adapted to other recycling process, transforming new materials using our RFM mechanical recycling and exploit the low density as a value instead than an obstacle. Next one, please. So the new refresh production line, we will make panels better, faster, and more competitive, with higher performance and with future alternatives also from a cost point of view to MDF and plywood. We are doing a lot of research also with SETMA and other partners to evaluate the results of fully recycled panel from wind blade. Next one. What we will need to do, what we will obtain, will it be competitive? I can say yes. Circular economy, for example, building components. We are making recycled components for shading facades and architectural components. 40% light than ceramic, 70% lighter than concrete, 96% recycled content. That makes lower cost of installation, lower cost of infrastructure. For example, these structure for making this facade, if done with ceramics of the original stone that was intended, had to weight something like 4 times more. Next one. Circular economy, cold chain freezer components. We are already doing a lot of several circular economy projects with companies that works in the cold chain and freezer. First, because it's a field where a composite makes already a lot of sense. In any kind of cold chain equipment, you have always water, liquid, condensation, and so on. And so the resistance, the water resistance and the sensibility to liquids of our panels is really ideal. It will offer better insulation respect alternatives, no thermal bridge, no rust, and no need for, or much less need to reinforcing. So it's something that it already find a really interesting application field to work on. Next one, please. Third application, construction. Formwork in recycled composite made with our recycled panels and profiles made in pultrusion, and then we will see that probably will be also possible to make the pultruded profiles with some fiber and materials from recycled slate. We are already offering a modular system compatible with the traditional steel and plywood panels, but with really it's lighter. It's a much longer life because again doesn't rot, doesn't rust, doesn't even need to be grounded for current or for flash protection. Next one. Plus, we are also working, and since we are believer in a strong cooperation, and we are obtaining really excellent results with other partners. So one thing that we are working on, and we will see in a couple of months, it will be competitive. An entire facade made from profiles from cut wind blade, and pultruded profile with the recycled glass fiber from Gjenkraft that could be used also for the insulation, our recycled panel, the blade cut from a TANF, and on and on. Again, something carbon negative, recycle very high recycle content will be da rispondi. And we think that will be something really interesting for mostly for the renovation of buildings like social housing, where it will be possible to obtain very positive result, low cost, and with also a good thing that this facade will be fully recyclable at the end of its life, again with more or less the same technologies. Next one. I thank you for your attention. I am open to any question and so on, and I did not made a question and answer because here probably we will need again another another webinar only for the question and answer because the aspects may be really different. Thanks thank you all, and field open for the next one.
Thank you so much. Okay.
Yes. Then I guess it will be me, but just a sec. I have a problem with sharing the screen. Just a sec. Some technical issue here, I guess.
Try now.
Now, yes. Then I need to bring back the presentation. Oh, just a second.
Don't worry.
It's always happens like that when you need it. Okay, now you should see my screen.
Yep.
Perfect. And the presentation.
There you go.
Okay.
Thank you.
Great. So, hello, my name is Marcin Rusin, and I'm currently the CEO in Gjenkraft. I'm also a co-founder. Quickly about Gjenkraft. We have established Gjenkraft in 2021, so not that long time ago, with one main mission, which still is to solve the challenge for the composites material, in particular with the focus on wind turbine blades. In terms of recycling or handling, managing waste coming from that industries. So with that focus, we have developed our own technology with main focus on the innovative scalability and economically available to support the transition of composite industry into more sustainable waste handling. With that focus, we've been also working with other industries, bringing along commitment for ourselves to work in the composite recycling market and expanding or bring and creating more industrial plans across the Europe to be able to process the composite waste. Let's come to our technology. We are basically focusing on thermal processing of the composite material. It means that under the control environment and temperatures, we are depolymerizing the resins to free up the fibers. This is a multiple thermal and mechanical process in which first of the steps is the pyrolysis, where under the oxygen-free atmosphere, we are breaking down the resins into gases that next are liquefied into the oils. We see an example of some oils received from the processing here. And from this process, we are also getting some fibers that later under the purification process are purified, cleaned, and ready for new applications. So in our multi-step processes, we are recovering fibers, which are the main focus for us in the Refresh project. And based on those fibers, together with other partners, we work some end products and that are valuable for the market, and a great example what you can do with the recycled fibers. And also Giorgio mentioned, with some solids coming for our process, we are also producing some construction materials like panels with Giorgio, but also we can produce other different types of construction materials with the use of our fibers. We are in Gjenkraft. We are not producing, of course, those products. We have partners like GIS or like Setma in the Refresh, which also we've been working on many different applications. We are delivering many, and our focus is to deliver clean fibers with specific mechanical properties for our partners, for our customers to be able to use them in their application. So a little bit more about the process steps. So first of all, in our process, we are downsizing the materials. In a Refresh project, the downsizing has been already done by ETA9 or MTB. And then we are getting the product, the materials, which we need to segregate, not only because of the chemical composition to maintain the proper quality of the products coming out from our process, but also to maintain the proper tracking of materials for the customers, so they're always able to track down where the waste that is coming from them is going next. And then after the proper preparation of the feedstock, we are going through the thermal steps where we're depolarizing the resins, recovering gases, oils, solids, and also the fibers. And then fibers are sent for the purification process, in which we are cleaning the fibers or preparing them for the application, removing the residues from fibers, making sure that the chemical composition or chemical purity of the fibers that we are delivering to our customer is the required level. It's highly important also because different application requires the different, of course, purity of the fibers. If we go for application where the fibers needs to have a proper binding with the epoxy, or that goes, for example, to remelting, we need to make sure that the fibers are perfectly purified and clean. In some application, this purification level of the cleanness is not that significantly, not that required to be that high, sorry. So it's important to adjust the process and parameters to obtain the proper quality of the fibers or proper grade of the fibers. And of course, after recovering the fibers and purify the fibers, we also need to post-treat them to obtain required length of the fibers. So we are able to prepare the fibers, which starts with a couple of millimeters, or in some cases even down to a couple of micrometers, up to a couple of meters. So different application has a different requirements, not only to purity but also to the mechanical or physical properties of the fibers. So when we joined the Refresh, we see a number of challenges for ourselves in the market and to our technology. Then most of those challenges was already addressed in Refresh or will be addressed in coming months. So basically the feedstock was very fragmented. It was inconsistent feedstock to the plant. That was also connected to the low awareness of recycling alternatives or the recycling possibility at all in the market. Also, we've been facing high logistic costs for the transportation of wind turbines to our facility, as the size of the blades can vary, but most of them are pretty large. So, and that's requires a new approach how to downsize the blades and transport to our location. And of course, we were challenged and still challenged by the pressure of the cost of recycled fibers versus raw materials, virgin fibers, which the glass fibers is pretty low cost, but on the other hand, the carbon fibers that also we are recovering and also are present in the blades creates or gives a competitive price on the market. So there's some pressure on the price, and it's very important to to have a processes which allow us to recover the fibers with a minimum cost to be able to compete on the market with the virgin fibers. And of course, we've been missing some criteria. Still missing some criteria on the recycling materials, what are requirements for those materials before they can enter the market. And that also is connected with the low adaptation of the recycled content in the new industry or in the industries across various markets, including wind turbine blades production. And last but not least is the scaling challenges. We had to upgrade the lines to reach to the certain throughput of the process to be able both economically available, but also to be able to satisfy the needs of feedstock on the market. And all of those was addressed, as mentioned, by in Refresh project. So what we've been mainly focusing on and what Refresh allow us to achieve was to upgrade our process. That before Refresh was mainly the batch process. In this project, we've been working with our process. We've been developing it further. We've been designing new lines, including continuous line that allow us to reach out the capacity of nearly 3,000 tons of composite per year, which is basically pretty large. It's industrial. We are going into industrial operation right now. So we are one of the first thermal recycling plant with that high capacity in the market right now. We improve also our feedstock control and the material flow through the process. We have upgraded our purification of the fibers, make it more stable and able to achieve different purities required by the market. We have also worked quite a lot with our partners to find out the applications and to make some demo products and application for the fibers. And of course, we are working on a definition that's very important for us on definition, what is required by the market, by the off-takers, so we can implement the proper regime into our process to obtain the required quality of the fibers. Yes, so what are the next steps for us in Refresh and outside Refresh when it's finished? We are going still to continue our work towards further scale up of our plant. We are aiming to go up 5,000 tons per year capacity in the next months, years in our current location, and also develop other locations across the Europe for other partners and to bring the recycling solution available in all countries in EU and also of course outside. We will continue optimizing our process and testing with the partners of Refresh, delivering materials and collecting the feedback to make sure that our processes, our outcome is meeting the requirements, and continue market development and onboarding of new companies or new waste streams into our processes. Let's go to the frequent questions that we are getting asked. I think those are the three most common questions we are getting. So the first of all, what is the quality of the recovered fibers? What is the process, if the process is economically available, and if material can be used to go back into wind turbines. So answering those questions right away. Yes, the quality of the fibers are a bit lower than the virgin fibers, and that's because we are processing the fibers first mechanically, then thermally, and then mechanically again. So there is some degradation if the material properties. That's also why it's very important to understand the requirements for the market, because then we are able to adjust our processes in a way to minimize the impact of our processes on the fibers quality. So by knowing exactly what our customers are expecting for the fibers, we can tailor the process in the proper way. Yes, but we need to be aware that the recycled fibers has some lower mechanical properties compared to the virgin one. Is the process economically available? Yes, it is, and of course this is why we are doing it. But we're still facing the high pressure from the virgin materials. So it's very important for legislation, for the one that is creating the laws, to make sure that non-sustainable solutions like landfills, cement kilns, or installation are not allowed, because then we are able to compete on the market, and that we can create a turnover that also allow us to further scale up the processes and deliver new materials and higher grade materials to the market, and also that our off-takers are willing to take in the materials for testing and for production of new product. And the last one, if recycled materials can be used for the blades, and I'm happy to say yes. And our colleagues, together with our colleagues from SETMA, we've been working on a demo blade. So you see in the corner, you see a picture of the blade that our colleague Andrea produced together with the wind blade producer. We produce a piece of the blade that is made in a combination of the virgin and recycled materials as a demo, to present that it is possible. Of course, it's still a long way before we can produce the whole blade that can be put it on the tower, but this is, I think, the first important step towards this holy grail, that we are able to close the loop and reuse the fibers from waste, from old product back to the new product of the same category. And that would be it from my side. Thank you very much.
Thank you so much. Okay, so now I think is Ignacio's turn.
Yeah. Can you hear me?
Yes.
Great. I'm going to use the full screen mode for the presentation. Here it is.
Thank you.
Great. So good afternoon, everyone. My name is Ignacio. I'm Technology Project Manager at CIRCE Technology Center, and I'm going to summarize the latest developments on the framework of the microwave-assisted wind turbine blades recycling. But first, a few words about CIRCE. CIRCE is a technological center based in Spain, exactly in Zaragoza, in the northeast of the country, with more than 300 professionals and more than 30 PhDs, so doctors, working on research, development, and innovation in the fields that are highlighted below. So within all these fields of knowledge, we are focusing our research within Refresh in these three categories: so energy efficiency and decarbonization, recycling, and industrial technologies. So all of you know the challenge of wind turbine blades recycling. So despite having several options, most of them are currently landfill or incinerated. So the possibilities not to do so are the blades repurposing for low amounts of material. One can create urban furnitures, but most of the wind blades are then recycled either under mechanical conditions or under thermal and thermochemical treatments. So my colleagues who were presenting the mechanical methodologies carried out at GIS, and also the thermal recycling through pyrolysis in Gjenkraft. So we are more focused in a particular case of thermal and thermochemical recycling, that is the solvolysis and pyrolysis. Both technologies evaluated at the same time under microwave-assisted heating. Why microwaves? Because microwaves are able to heat selectively the material that we want to pyrolyze or solvolyze, and decreasing the starting up and shutdown periods along the process. So as you can see here on the top left, the temperatures rise too high to reach a constant temperature for pyrolysis compared to conventional heating, but also the full depolymerization times for resins that are contained in the composites are drastically decreased by using microwave heating. As you can see, more than 5 times faster is the process. And the reason is that we can heat selectively the material that we want to process. being the surrounding atmosphere completely colder or much colder. So in this way, we can even control how the gas phase, the organic vapors that are generated through pyrolysis, we can control how they evolve, how they keep on reacting due to this temperature gradient between the sample and the environment. So as you may know, resins have very strong heat transfer limitations. So the heat transfer is very pure. And that's why large temperature gradients along the thermal medium limit the recycling process controllability. And furthermore, gas phase cracking in the hot reaction system atmosphere also limits the oil production distribution controllability. So the molecules that we're gonna get out of these resins. Contrarily, microwave-assisted heating gives some advantages. As said, fast, selective, and volumetric heating that aim to control the pyrolysis process and the oil product distribution. Furthermore, we have realized that the apparent temperature of the process is significantly lower than under conventional heating, and that gives a better control on the mechanical properties of the resulting or reclaimed fibers, as well as of the oils. So to carry out the proof of concept of this technology, we count on two different reactor units, the microwave pyrolysis process unit and the microwave solvolysis unit. Both microwave cavities can hold tanks up to 1 liter capacity, and what we were evaluating are the process conditions, so temperature, residence time, and also flow rates, to get the maximum in terms of oil yields and productivities, as well as clean fibers. So as you can see there, by pyrolysis, we are able to separate fibers, but they become coked unless we use a kind of a combustion step to remove these carbon deposits. While under solvolysis, we are getting clean fibers and oils. The quality of oils will be compared later. So under pyrolysis, we were processing both epoxy and polyester composite resins. And we found that the most impactful parameter in the process operation is the pyrolysis temperature. So if the temperature is too low, we cannot remove the resins. If the pyrolysis temperature is too high, we damage the fibers. They start to melt. Under polyester resin, we observe more or less the same, but in this case, the residence time was to be optimized because the time that vapors spent in the hot zone of the reactor has a big impact on the quality of the oils that can be obtained. Regarding the oils, the ones from epoxy can get up to 80% in weight of phenols, mainly P-cuminol or BPA, that are the chemical building blocks of the epoxy itself, so they can close the cycle towards the production of new epoxy resins. In the case of polyester, what we get is phthalate and phthalic acid derivatives that represent more than 70% in this case. But if we look at the atomic composition, carbon, hydrogen, oxygen, nitrogen, the composition of these oils would be also suitable as fuels, as precursors for fuels. If we go to solvolysis and we do the evaluation of both epoxy and polyester FRP composites, what we get is that the fibers are cleaned, more cleaner than those under pyrolysis, but they still have deposits, not of coke in this case, but of the catalytic salts that we use for enhancing the depolymerization of these resins. The composition of the oils is rather different and is strongly dependent on the solvolysis medium and catalyst that we are using, and the amount of oxygen in the atomic composition of the oils discourages its use as fuel, but also discourages use as a chemical building block. So comparing both pyrolysis and solvolysis, we have three categories for comparison. So the oils, the fibers, and the process itself. In case of pyrolysis, the oils have a relative high value as chemical building blocks. Phenols and phthalic derivatives products are obtained, and they can be used as additives for naphtha production, as said. Regarding fibers, they have typically low value, although better textural properties preservation with respect to the conventionally heated pyrolysis process due to the use of a lower apparent process temperatures, and the process itself is energy demanding due to the high temperature, roughly 400 to 500 degrees Celsius. But the separation, the isolation of the oils from the fibers is pretty easy. So if we want to recover clean fibers, we need a post step based on co-combustion. Regarding solvolysis, the potential value as building blocks for the oils strongly depends on the medium catalyst and operating conditions being typically lower than that of the products obtained under microwave-assisted pyrolysis. The fibers have relatively low value with no structural damage and cleanliness, but the length of the fiber is rather low because we need to pre-shred them to be fit on their stirred tank reactor type. The process is typically less energy demanding in terms of thermal processing, but the complexity of oil isolation and the materials demanding, so solvents, catalysts, post-processing agents, makes the process less attractive. So frequently asked questions that we normally get: which is the most appropriate technology among or between microwave pyrolysis and microwave solvolysis? Well, we did a techno-economic assessment of both technologies, considering the whole value chain, namely from the shredding and sorting and pro-processing through the thermochemical process and oil separation from fibers. And what we got is that both the OPEX and CAPEX of the microwave-assisted solvolysis is almost twice higher at this bench scale than those of microwave pyrolysis. The analysis, of course, excludes the cost-benefit assessment derived from the recycled product's quality and the potential selling price. But is this technology scalable? The answer is yes. We create the first of a kind microwave-assisted continuous pyrolysis process for the composites and also from polyolefins mixed waste that is able to process up to 30 kilograms per hour of shredded FRP waste with a nominal input power of microwaves of 9 kilowatts. And the output of the process are sorted and cleaned fibers together with pyrolysis oils. By evaluating the techno-economic analysis of this new pilot plant that has been already built and is under commissioning at CIRCE facilities, we got a 120 times normalized reduction of energy to run the process under continuous operation, plus 58 times OPEX reduction and just 5 times CAPEX increase with respect to these bench scale plants, to hold 1 liter capacity. So conclusions and outlook. The microwave heating boosts the energy efficiency of wind turbine blades recycling down to 3 times lower consumption per kilogram of FRP treated. Enhances also process controllability, oil products distribution, and also the reclaimed fibers quality, keeping up to 80% of the original mechanical performance. Both pyrolysis and solvolysis technologies were experimentally assessed. Both may provide fibers and oils. And the techno-economic assessment reveals that the overall cost of pyrolysis is roughly 2 times lower than that of solvolysis. The quality of fibers are comparable between them, especially if we apply the post-combustion treatment to the fibers from pyrolysis, while the oils from pyrolysis are more interesting from the end use point of view. And finally, a new pilot plant is being commissioned at CIRCE premises to assess the process scalability and energy efficiency of this kind of microwave-assisted pyrolysis solution. The nominal or maximum capacity of the plant will be 30 kilograms per hour and will be available for bench trials for potential investors. And that's all from my side. Thank you very much.
Thank you. Thank you so much, Ignacio. Okay, so we have Jean now. Yes, I'm sharing your screen as well. Just a second. Okay. Great.
Okay,
Thank
my
you.
name is Jan Kaspar. I'm from Enecolab, and our work concerns the thermochemical treatment of dust and fines. Why this is important within our project? The point is that within our project, we effectively find when we start from the wind, from here, we find that there is a lot of production of dust and fines in every part of our processing, which means that about 50%, up to 50% of the material, of the starting material, is essentially material which is difficult to trade and which needs, of course, to needs to be to attain some valorization. So our mission in this project was to find a way to minimize the dust and fines production, because this is essentially one of the most important problems in this processing, and then cooperating its capture. And the third point is the one which I'll be talking today, which is the waste valorization in terms of energy. So let me go with what is there now. Normally, as already has been told, is that dust and fines presently are either used in the cement factories as well. For example, in France, it is quite widespread use, or landfill, which of course is undesirable. The alternative was we have been talking, we have just heard about the composite or some thermochemical processes. Essentially, those thermochemical processes so far discussed have been best processes, whereas in our case, we work on a continuous process. So essentially what we do in our job is to have some waste. Of course, the process is tuned in this project towards our dust and fines, but could be possibly any kind of waste which has some significant part of organic waste portion. We pre-treat and move it into a reactor, which is a pyrolysis reactor, and eventually there is a post-treatment. The main product which are interesting in is the syngas. The reason is that production of oils or whatsoever normally leads to complex mixtures, which maybe for application need to be separated or so. Whereas syngas is a quite effective energy carrier, and this is what we want to do. The second aspect is that during this process we obtain inertization, so we can have even a toxic waste, which may end up possibly with a not toxic waste, which can be discharged. So what essentially we do is, as I said, is a high temperature pyrolysis. We can work in this range of temperature between 800 and 1,000 degrees. And the main product which we want to produce is the syngas, which eventually can be purified and used as a syngas, or even simply by burning and using it for heating or for energy, for electricity generation. The residual solid, of course, might be post-treated because of normally we have gases, char, liquids, and inorganics, which are produced by a pyrolysis process. And of course, under our conditions, what we want to minimize is the liquid production and char, and of course, possibly the char as well. So these are the objectives of our project, in the sense that what we are looking out is to obtain energy from here, to obtain as an energy carrier. So clearly, within this project, we have quite a number of problems and quite a number of variables which has to be under investigation, and effectively, we are just optimizing our process. And because at first we have to resolve many problems which are due, for example, to transport of the materials, because it's the apparent density is sometimes very low, which means that you need an effective transport within the continuous reactor. Find the appropriate conditions, because the proportion of fibers and resins is quite variable. As I haven't shown before, it may be between 30 to 70%, so very large conditions. And of course, the amount of gas produced is strongly dependent on this proportion here. Clearly, the kind of resin of course also impacts on the calorific value. And there is also some process parameters which we are optimizing. What you see here is a table which reports some examples of a laboratory scale which can process a kilogram of SOS, and an industrial scale of our reactor, which I will show you in a next presentation. And you can see that essentially we have a quite significant part of the CO2, because this is arising from the oxygen which is contained in the starting polymers, of course, and the resins, but reasonably appreciable CO is calorific value which is obtained in this project. If I show you just the reactor is quite small. This is a reactor which is capable of treating up to 20 kilograms per hour of material. These materials can be made modular. These reactors can be made modular, and so we, for example, are working on a parallel projects where 10 of these reactors are used in parallel and can process tons and tons of materials per day. And essentially, what is important in all the discussion is that we have at this point a gasification efficiency which is about 0.2, 0.3 cubic meters per kilogram of material. But the important thing, I think, is that we obtain a significantly higher amount of energy in terms of from the gases that are produced in the product. We don't consider the energy contents of the char, which is coming clearly together outside from the reactor, which can be then treated and under oxidative conditions and generated further heat, which is quite high. But these values, to be honest, are quite low in this case, because we have been using materials which has a relatively low carbon contain. When we start from some other materials, we can obtain an energy which is about even twice that of that employed for our treating. So coming to the summary, I think that we have shown that this project, this pyrolysis reaction, is able to convert these materials and obtain syngas, which is a useful energy carrier. Preliminary results, as I said, not optimized one, shows clearly that the amount of energy recovered exceeds that used in the high temperature treated. And essentially, what is the idea of the JOS project? It is designed to be integrated within an industrial process. This is an important aspect because as long as you move the waste of your product within the project, it's not classified as waste. The waste will be the final product of our product, which, however, we can inertize even toxic materials. And most importantly, we recover and have an exceeding value of the energy content. So I think we're here to thank you for your attention. And of course, we are open for questions. And thank you very much.
Thank you. Thank you very much. Okay, so we have the last presentation, Raphael.
Okay, good afternoon, everyone. I mean, before entering in this, because I need to speed up, we are late, but what we have seen since 1 hour and 20 minutes is really a very good message and gives some hope, because we started this project less than 3 years ago, and you see how the model is functioning. You know, the technologies are there. We also demonstrate there is business case. There is a good cooperation among the value chain. We also have demonstrated that there is the possibility to have applications for secondary raw material, which is also great. So what do we miss? And this is the transition to the regulatory challenges. So in very short, EuCIA first is the association of the European composite industry, and we are the unified voice of the European sectors. We represent the different national composite industry around Europe, and also different industry sectorial organization, and also some alliances. So I will come back shortly on that. So altogether, we represent more than 85% of the European composite industry. That's just one slide. We are talking about the technologies. Today, you have seen that it's possible to recycle and to reuse, but we wanted to estimate what is the volume of composite material reaching the end of life. And theoretically, it's 900 kilotons in the year 25, but we know that the I'd say accessible potential is around 230. So which gives you already a size of what we are generating every year. What I wanted to focus is what the initiative of the European Commission, they would like to set up the Circular Economy Act at the end of next year. And they launch a consultation which was ending at the end of, on November 6th, exactly. It was really to enhance the European economic circularity and competitiveness, and promoting more sustainable production, circular economy business model, and decarbonization. So on that, I will skip that one. But what you have to see here, it's really the goal is to create true single market for secondary raw material, and also to increase what they call the rate, the circularity rate, and that's the way they calculate, which is in 2023, 12%. So we will see that. So the Circular Economy Act aims to boost the supply and demand for secondary raw material by removing barriers, and that's the challenge. Aim to reach the EU circularity rate up to 25% by 2030, 4 years from now. Okay. So there is two main pillars for them. It's the electric and electrical waste, and also the single market reform. So it tells that at the European level, there is some work to have the right regulatory, so the regulation. That's really a good positive message. So what we so I go straight. There were a questionnaire, a survey for all the industries, and here I just give you one example. That was the first question. To what extent do you agree with the following statement about the barriers hampering the UE single market for secondary raw material? And then you have a list of statements where we had to agree as EuCIA, for example, but also many other associations. What was the first statement was Does the price of secondary material is in general higher than the price of primary raw material? In general, we said yes, we agree. And after with the quality, we said that the secondary raw material could be in quality as good as the virgin material, depending on the application you are targeting. So that's we went through that, and we worked actively for the months of September, October on that. We also worked with our association partners. You have here a list of the cement industry, EBI, which is the boating industry, then resin manufacturers, epoxy, the glass fiber, of course, the glass producer, urban glass producer, polyester and polyester resin, and Wind Europe. So what we are saying is that there is several technologies to reuse or recycle composite material, and the technology are sometimes we can say mature, and making composite circularity viable and realistic options. That's, I think, with the presentation we got today, it confirms. We have absence of supportive regulatory framework and incentive, and it's where we really need to focus. So we I don't know why it doesn't work here. Oops, I cannot go to the next slide. Okay, here it's the policy ask. We split it in 5 parts. So we really need economic incentive to recycle materials. So, for example, stimulate the demand for secondary material by reduce VAT, public campaign to raise the awareness of recycled technology, provide clear waste codes, because you were all talking, about the different steps in our refresh program. But if you have to move the material outside of the country, then it's challenging. So we really need to have dedicated waste code, dedicated for wind, dedicated for boats, dedicated for composite, and facilitate the intra-European transport of composite waste. This is really central also. Recognize all forms of recycling. We are not, of course, promoting one technology or another one. You have seen today pyrolysis, solvolysis, mechanical recycling. We also recognize that the cement co-processing is a recycling technology. There is an established map of cement kiln around Europe, and this technology can be considered today as a recycling technology. It's not the only one, but it's an option. Set clear targets. Of course, when we want to progress, we need to measure and we need to have targets, and gradually phase out of landfilling. But we don't want to do it from one day to another. We need to do it gradually. Otherwise, we will discourage, and at the end, it will be counterproductive. And of course, facilitate transport, permitting, and infrastructure deployment. So all those points are really what we are going to continue to advocate with the European authorities. Also, two short slide on an initiative EuCIA launched now back in early this year, but being in the operational phase since the end of August. This is the European Circular Composite Alliance. Some of our refresh partners are members, and really here we have dedicated different working groups how to address it and to increase the circularity. So here, for example, it's the example of the Industrial Recreational Working Group, where we have the wind blade entering in this segment. And we will have the first General Assembly on December 4th here in Brussels. And if you are not a member or if you are interested to join, you can go on the EuCIA website and you have all the informations. That will be a really important day. We will have in presence the representative of the European Commission from DG Mare and DG Grow, because they also they recognize the importance of such an alliance to provide some policy ask for future regulation. So the exchange will be really valuable. And that's it for me.
Great, thank you so much. Okay, so we reached the end of the presentations. We have the Q&A section now, so I kindly ask all the speakers to turn the cameras on so we can address the questions that we still haven't answered to. and I'll bring everyone on screen so you can answer them directly. Okay. Great, thank you. Okay, I think I'll leave the floor to Daniel, so if he wants to...
Yeah, I saw a lot of questions in the chat, but I think that they all already have gotten an answer. If not, I kindly ask you to post them in the Q&A section so that we can answer to them. But I think they have pretty much got a response. Anyways,
Daniel, I see one question about cement co-processing being in strong competition with other RDF tires and so on, which is correct. And for the moment, composite material are not yet positioned at the right level because they need a certain feedstock when to start to implement this type of thing. But also you have some of the cement producers are anticipating that, for example, the tires volume will decrease in the coming years, and that's the reason why they are considering alternatives. So that's just to answer to this question.
Okay, thank you. So I see in the chat, just to clarify, no operating commercially solution available already in Europe. I mean, if we speak about the whole refresh solution, it's not, I mean, the whole solution operative, not yet, but the single partners are already working on its own because every partner has exist before the refresh project, so everyone is already working in this sector. And basically, for example, GIS Recycling is doing already the mechanical recycling process on the composite materials and so on. But what we see in the refresh project are the upscaling or I don't know, the other progress in also in the research and development sector for each technology, and the whole solution which should take the wind blade from the decommissioning till the end product. So if you are talking about the whole solution, it doesn't exist yet commercially. The other single steps, in some way, they already exist. Then the other one for Marcin, is the composition of the obtained pyrolysis oil known? Based on this, any potential application for this oil?
Yes, we know the composition of the oils, and of course the composition vary depending on the feedstock. That's why I highlighted the need to closely monitor what is coming in to us, and separation, segregation before the processing. We are working on the applications, different applications for the oil. Of course, our goal is not to use the oils in the petrochemical or basically to the fossil fuel production. We are working with the purity of the oil that will allow us to use the oil in the chemical industry. We have some leads, not everything is solved yet. We've been testing the oil for some chemical production, including possibility to recover some building blocks for the production of new resins. But the work is still ongoing, and that's the direction we are aiming for our oils. Hope that's answer your question. Maybe I can also add that the composition of the oil is pretty complex, so it includes many components. So it's not a simple composition. It includes many components, and then they all require post-processing to be able to separate different fractions or different components to be useful for chemical industry.
Okay, thank you, Marcin. I see no other questions. Different solution for recycling. On which criteria I'll have to select one among others. I mean, we don't select. I mean, the selection of the correct recycling process for each wind blade, we can say, it's determined by the various aspects, basically the condition of the blade, the market demand, a lot of factors that could lead you to choose a different recycling process for each blade, and this will be managed through the AI tool, the tool I was speaking about in my introduction, in the refresh presentation, which basically takes all this input information, for example, the technical check on the blade, the market demand, and so on, and basically crossing all this information, it will decide what is the best recycling process for that moment, basically. See, Anurag with the raise hand. Okay. Okay. Another one. There is. How can competitiveness be achieved in contrast to recycling? For example, cement works at the cheaper option for wind blade decommissioning. I mean, the first fact is that if you want to go on a secondary raw material, obviously it's another story. But if we speak about end product, those kind of end product carry on an added value, because if you are selling like a new end product, you have basically outbounded the barriers that are normally on this material, because as I said before, the virgin raw material, it's way more cheaper than the recycled one for obvious reasons. So if you just look to recycle the materials itself, it's not very competitive, the solution, obviously. But the cement, it's one of the options that we are considering also in our project. But the fact is that there are other and the final experimental data will be shared once all the technologies will be operative, because for now we have some analysis, some business cases, models, LCA, LCC, but these are not based on the real and final data, because we are finishing the deployment of each technology. So this will be basically a matter of the last year of the project, in which we will get also maybe some data on the cost of euro per ton of material recycled, something like this, that could show and could give a clear picture of the benefits and all of this. But also to answer to the question, if we have like the euro per ton, is that as I'm saying, we have not a single euro per ton figure available yet, also because it depends on the specific route you are choosing. But we will for sure work on also giving maybe like a number which is a fixed number, and then it includes also the choice of the correct recycling process. But this will be a matter of the last year of the project, basically, because all the data will be available once all pilot data from partners are fully and finally integrated, which is something that will be happening soon, because yeah, we are finishing basically the deployment phase and begin the final testing phase. Okay, let me scroll. when we can download all the slides. I don't know if we have already thought about this to download the slides. I don't know, Martina or Amanda, if
Yeah, I was thinking maybe Amanda, if you could confirm this, please. Will there be a section on the website, the project website, to download the slides, or maybe we're going to share them somewhere else? I don't know.
I think we will probably share the recording.
Okay.
And then, because the slides is going to be a very big file, but we can make those available to people on request.
Great, thank you.
it's okay. It's okay. I think it's the best solution. Also, if you send us an email, we can basically share every pack of slide you desire. That's only the problem is that they are big files. So yeah, we have to share one by one, I guess. Okay, let me scroll the other ones. What is already done? The pyrolysis soil. What is already done? The pyrolysis soil. I'm not sure on what this does mean.
Maybe the question is about. Oh,
go on,
please,
Marcin.
please. I've been speaking. Now your turn.
I think it refers to the final use of the recycled oils up to date. So, in principle, they are being used as fuels after purification or upgrading of the obtained oils via pyrolysis or solubilisis to remove the traces of nitrogen and oxygen. After this post-treatment, they can be used as fuel, as energy vectors. But of course, in the near future, we want to get the best compositions possible to get some pure monomers to be able to recycle them into new resins, let's say epoxy and polyester.
Yeah.
Do you want to add something, Marcin, on that?
No, I think you answer it okay. So.
Okay. Another question on how many wind turbines blades per year can be recycled with the existing solution. I think it's a kind of a matter of the size of the plants. So, for example, with the mechanical recycling process, we are aiming to upscale this to over 5,000 tons per year of material treated. So that's an example. I don't know if you want guys to add something on this matter based on the data of your plans. I don't know.
Yeah. I think it's difficult to say how many blades because depends on the blade generation. So we have old generation of the blades which can weight as little as 1.2 ton. One of the blades that we are getting now from UK, but also we have blades that are weighing 30 tons. So some newer generation blades 80 couple of meters in length. So I think it's difficult to say by number, but if we look on the capacity that recyclers, we as a recycler, so it means us and the geese at least, we are aiming for capacity. We are aiming for around 3,000 tons yearly, and geese, I think if I remember correctly, they're also aiming for something above 3,000 tons per year. I think then we are talking quite a few blades that can be processed, more than 6,000 tons. That will be quite a few blades that can be processed with our technologies. It's still not much if we think about the forecast for coming years in terms of how many wind turbines will be demobilized or how much waste from the production we have available. But I think it's a good start, and both us and Gis, we are still aiming to further scale up. So we hope we have enough capacity to process coming wave of composite waste.
Okay, thank you, Marcin. So, what are the best applications of recycled glass fiber found so far, and how economically viable are they? So, to sum up, the most promising application for the recycled glass fiber that we have currently identified are basically the construction panels and formwork through the mechanical recycling route, the non-woven mats for the insulation and wind blade skins, cast polymer formulations using the powdered fibers, and the pultruded or infused profiles when longer fibers are recovered from the thermal recycling. And these applications are all considered economically viable when integrated into circular business model because they basically replace the virgin raw materials and as I said before, they create added value products, not only the material the material recycled. However, the glass fiber, as I said before, has lower market value than carbon fiber. So the competitiveness depends on the scaling up of the processes that aim to reduce the logistics and the energy cost, which are barriers that we are aiming to pass through. I mean, because and also the lab scale trials and demonstrations are ongoing to validate the performance and the cost efficiency before the final industrial deployment. But those are basically the products that we have identified so far to be the best applications for those concepts. The other one, what's the scope of thermoplastic resins in the recycled wind turbine manufacturing? So the thermoplastic resins play in general a key role in making future blades more recyclable and in integrating recycled outputs into new products. In Refresh particularly, we are using them together with the recovered fibers and fillers from the mechanical and thermal recycling to manufacture the new composite part, for example, the pultruded profiles, the panels, and this also is good to enable the design for recycling. The thermoplastics in general offer lower environmental impact because they can be remelted and reused in general, and they are easy to be reprocessed at the end of life. And also they are more compatible with the recycled powders and mats. And in general, all those aspects make them the preferred metrics for the circular blade manufacturing. Okay, so
If I just, Daniel, if
okay.
I quickly could
Oh,
add
yeah.
or comment to your
For sure.
previous question or your answer. I don't think there is one best application for the fibers. I think the market is so big and the variation of the product is so big that there will be many applications for the blade. So what Daniel presented or mentioned, this is a great example of what can be achieved. But this is probably just a small amount of the possible applications for the fibers. And I don't think we can say which is the best because yeah, it's different products, different applications. Customers will have a different demands. So there's for sure there's a lot of products, great products that can be made with the fibers. And I think our work will continue within Refresh, and also probably we will work also outside Refresh on that and create many more valuable product and examples of composite recycling. Thank you.
Thank you. Okay, I see another question for Ignacio. What is the current TRL maturity level of the microwave pyrolysis and microwave solvolysis?
All right, I can comment on this. Regarding microwave-assisted pyrolysis, there exists some demonstration plants at industrial level. We can say TRL7, but for biomass processing, biomass pyrolysis, or even waste tires pyrolysis. But for composites coming from wind turbine blades, I would say this is the first attempt, the pilot plant that I was presented at least at Europe level. So we could say between TRL 5 and 6. The TRL for microwave-assisted solvolysis for this specific waste is even lower because we need to combine high temperatures with high pressures. So the capex for this equipment and the construction of big reactor tanks that are able to reach up to 200 bar is very challenging, of course. So the TRL can be 4 to 5 for solvolysis and 5 to 6 for pyrolysis.
Okay, thank you. Let's see the other ones. Okay, what is the quality of resin after mechanical recycling? Okay, the fact is that after the mechanical recycling, the resin does not retain its original structural properties, obviously. It's converted into powdered or granulated material that will act as a filler or like a binder in the new composite products. Example, the panels, the insulation boards. Obviously, it from the mechanical recycling, it cannot be used as a high performance matrix like the virgin epoxy. But anyways, it provides environmental benefits because if you are aiming to low to medium grade applications and also in those panels, it's perfectly fine to use this kind of epoxy resin recycled. Otherwise, you should be using the virgin resin, which obviously it's much expensive and also less sustainable. But I mean, from the mechanical recycling, the quality is not so good, but you can use it as a filler or binder in those kind of application, and it works perfectly fine because those panels have the characteristics that they are meant to have. I mean, so okay. Another for this one is for Raphael. The waste codes. Do you know of any cases where blade waste has been classified? Okay.
I'm sorry, but no. Most of the time it goes on municipality waste code, but to my knowledge, there is not yet. Maybe some other have different experience in the room, but I'm not aware of any. That's a good question.
Okay.
Also, we don't have a specific code when we transport, not we transport, but our partner transport waste to us. We don't have a specific code on the blade. So that's currently, this is correct. And of course, there's some projects, EU-funded projects and some initiative to address this challenge, to guide Commission and how to make a legislation to improve and simplify the transport of the waste. Right now, we need to act with what we have, and looking on the in the different countries, we look how we can classify the waste to be able to transport. So currently, I think I would say that this is based. The codes are given based on the experience of the transport companies and us how to transport the waste. So bit complex process, but we really hope that this will be solved in the near future.
Okay. So, some LCA analyses were presented by RINA. Could you please comment? Okay. So, speaking about the LCA results that I have presented before, those results are preliminary results that are not still based on the real data of the, the plants that are being deployed now, because obviously if we are finishing now the construction, they are not the final data. So this was like a preliminary LCA with the data from the existing plants, and real data, not something which is only by literature. So they are the promising results that we have showed in the LCA are not kind of fake. So first of all, and secondly, basically what we have presented is that we showed that the recycling routes deliver a clear environmental advantage compared to the landfilling or the incineration, which are the most common ways to treat those kind of wastes if we are not speaking about the recycle. For example, the mechanical recycling of a blade composites can reduce emissions up to 3,000 I don't remember. Yeah, it was like 3,000 and something kilos of CO2 equivalent per ton versus the virgin epoxy production. And also, this was an example basically of what I have shown and the explanation of the number that I posted under the graphics. Same goes for the thermal and microwave assisted processes. That also showed a significant benefit when energy recovery and fiber reuse are considered. So those basically all of those data fully aligns with the circular solution that we are proposing to outperform the traditional disposal methods like the landfilling or the incineration, basically. I think it was like the last question that I see. I hope that I didn't
we have
forget
other
anything.
questions in the Q&A section.
Okay, let me
them.
check. Let me check. Okay, the first one was, I see the waste codes. We have already run through that. The cost of the recycling per ton is something I think I have already discussed. There is a question for Jean-Baptiste. How do you compare your technology of on-site cutting with your competitors? With what that I mean, what is available in the market? Okay, I think this is the last one we didn't answer.
So please, just a minute. I just opened the Q&A question. I can see the story. I can read the question. I don't know where it is.
I'll copy it in the chat for you. Just a second.
Okay, thank you.
Yeah.
Can you see it now?
Yep.
Thanks.
Yeah, we can compare it because usually the traditional method is with hydraulic shear. So it usually not make some parts of blades. And we also manage the water process in order to manage the dust in the environment and for the workers. So maybe the difference is like here. In the presentation, I show one picture of excavator with an hydraulic shear. And with our experiences, it puts some little parts of fiber and resin all over the work site and all over, depending on your on fields on natural park, for example. So I don't know if I answer the question, but it's on this way. Is it okay for you? I don't know who is it, but
I think it's okay.
Okay.
Seems to be okay. Do not hesitate to contact me by mail if you want some more information. I think everybody here are available for an email or phone contact or something like that. I speak for all the partner of Refresh, of course.
Oh yes, for sure.
For sure, Daniel. We are okay.
No,
with
yeah,
that.
we had posted our email contacts in the presentation, and also there is the section in the website, the contact us section. So if you want to further discuss with us, we are happy to discuss. I mean, so you can contact us as much as you want. So I don't see any other question here. So
Yeah, I don't think we have any more. Okay.
yeah.
Perfect. Okay.
Yeah, if we don't have any other question, I think we can close here.
Yes. Okay. Thank you so much for joining. We will share the recording of the workshop soon on our YouTube channel. And as we've said in the chat, if you want the slides, we can send them to you if you contact us on the website. So thank you again, everybody, to the speakers as well, and see you soon. Bye.
Thank you. Goodbye.
Bye.
Thank you very much. Goodbye.
Thank you. Goodbye. Thank you.